Hello, I'm Th.e. I'm a KMP developer, and today we're going to continue our journey on how to program from the ground up series, and we're going to be doing talking about multiple inheritance. Oh yeah, I got an update. Tech support called on the old portal back there. The tool broke. It was broke. It broke. They were testing it out on one of their things to make sure they could do it the first time when they came out, and it broke. So I gotta order another tool, and hopefully they'll be out. They said Tuesday. We'll see. Okay, so here's multiple inheritance. Allowing for multiple inheritance in C++ was a mistake, and it was removed from Java, Kotlin, and C# for very good reasons. What's multiple inheritance? It's when you do this. It's when you do this. Okay, first of all, why would you do this? You have the abstract class animal or interface, well, not interface, but abstract class animal. This is interfaces you can do this stuff with, like abstract class, because you only have a single. You have to get everything from both. So let's say you have a class cat and a class dog, and they both are implementing method make sound. And then you have another class that extends cat and dog at the same time. So when you call make sound, what do you expect to have happen? Do you want to call the cat? You want to call the dog? Okay. So that means you got to know the internal stuff. Like, okay, for systems level applications, I might see a reason for this, but for just regular old applications, like why would you? If somebody can tell me a reason why you'd ever want to do this in an applications level, not systems level, applications level, even in the systems level, it's just really odd. But there's a reason why they wanted to push for it. And I have to assume it has to be that some system level optimization thing that they wanted to do. So, okay, so here's not that one yet. So you can copy and paste this example, which is all C. This is the only C I'm gonna write, or C++. I like C, but C++ I'm not a fan. So, as you can probably tell, so that's the only C++. And I had to get a help from good old ChatGPT to make that stuff work. Well, actually, yeah, that was it. Okay, so here I've pasted in the online compiler, and here's the class animal, and your class cat extends from animal, class dog, animal, and then cog, cat, and dog. And there's nothing here. So when you do create the cog object and you call make sound, like you would on any other thing you would inherit from and have a sound thing. Imagine there's a whole bunch of these, right? And this is all being done through the code base. You have to know. You have to pick one because it gives a compiler. It says, "Hey, what will this print?" Make sound. It says error. Request for member make sound is ambiguous. C++ has the best error messages. It doesn't know which one you mean. So if you go in here and you choose, let's choose the dog, and then it'll work. Because it's going to call that one. But you got to know which one you want, right? You got to know dog is implementing this animal thing and that it's going to have its own thing. So that's the main issue here. It's not like a huge big deal because we're like, why would you want to do this anyway? But here's a cartoon about it. Just add a little. I made this little cartoon based on somebody else's cartoon. Just add a little multiple inheritance I heard about at the conference last week. Should be fine. 2 weeks later, what the hell is this do? All right, let's listen to. Okay, quick goofing around. Let's listen to this gentleman, Cody with John. He's really great for Java if you want to learn Java and OOP and some OOPs. He's still slightly cop. He's cop level stuff. So I'd like to see what he has to say about Boop. All right, here we go.
But what exactly is multiple inheritance? Multiple inheritance is when one class has more than one parent class. So let's check out what that would look like. So here we have our cat class that extends from the animal class. Let's say that on top of that, we had another class that extended from animal called dog. And remember, there's nothing at all wrong with that. This is not what multiple inheritance means. A class can totally have more than one child class. But what if on top of that, we wanted to create another class called cog that inherited all the features of both a cat and a dog?
By the way, I stole this example of cat and dog with cog from this guy. So I take no credit for that.
Concept, that seems like it might be okay, right? But let's see what happens when we try to implement that in Java code. So let's hop over to our cog class. Notice right now it's an empty class. It's not extending anything. So first let's have it extend the cat class. Okay, that all seems to work fine, no errors. But when we try and add the dog class, we now get an error. And it
So he's showing you Java here. I showed you C++, he's showing you Java.
says class cannot extend multiple classes. So this is Java telling you flat out, you can't do multiple inheritance. You're not allowed to inherit from or extend more than one class. So clearly, Java doesn't allow multiple inheritance. But now the question is, why? What's the harm? What's the problem? A lot of people, when they talk about potential problems or issues with multiple inheritance, they'll talk about something called the diamond problem. Some people even call it the
the deadly diamond of death.
deadly diamond of death. Sounds pretty scary, right? Well, here's what it is. So let's say that we had our classes set up just like we do here. And then
If they call it that is because so many people try to do this stuff, this crazy stuff, and they don't understand this. Like, you're not supposed to use every single feature in the language and every single code base for all the for any, you know, just then you're really doing the oop. And people went nuts with it, and it killed code bases and projects. So yeah.
let's say that in our cat class, we implemented that make noise method in a certain way that would make sense for a cat. So in our cat class, it might make sense to print out meow. Terrible handwriting, but you get the picture. And then what if similarly over in our dog class, we implemented that make noise method in a way that made sense for a dog. So for a dog, maybe we would print out woof. But now we have this new cog class, which we're trying to have inherit from both the cat and the dog class. And of course, since it inherits all the methods from both of its parents, it's going to inherit the make noise method from each of those parents. But the problem is it's completely ambiguous which version of the make noise method that this cog class should inherit. Should it?
It's ambiguous. A big word for, I don't know which one you mean, dude. You kind of like are making me pick here, and I don't know which one, and I'm not going to pick for you, so Python picks for you. But it's like, it's going to say, you know, this one's going to say, no, you're going to have to tell me which one.
Inherit the functionality from the cat class that prints out meow, or should it inherit the functionality from dog that prints out woof? This problem is often called the diamond problem, perhaps for obvious reasons. The pattern of inheritance that
Oh, I didn't see that. Ooh, it's a diamond problem. Ooh.
causes this kind of issue is shaped like a diamond. So what does Java do about this? Well, basically, it just doesn't allow it. Java doesn't allow any multiple inheritance, so you will never run into the diamond problem.
So I did find a way to do this in Kotlin, so we'll all discuss that in a minute.
Like I said in the intro, there are other programming
Not that you should ever do it.
languages like Python and C++ that do allow multiple inheritance. So what do those languages do when the diamond problem comes up? For the most part, they just kind of pick one. And as the programmer, you just have to know how that particular programming language chooses
Seems like Python picks one, but C++ you have to tell it, which is annoying.
which one that it accepts. For example, let's say that this was a programming language that did support multiple inheritance. If you were allowed to extend both cat and dog, and you were in
I have that already, so I put that down here. Let's see. Okay, here it is. This is the thing.
those developers, which makes sense. One of Java's original creators, a guy named James Gosling, actually wrote about it at the time. He said, Java omits many rarely used, poorly understood, confusing features of C++ that in our experience bring more grief than benefit.
He's understanding the problem.
And one of those was multiple inheritance.
Okay, so I'll let you listen to what he has to say more about that. And, oh yeah, I made an example here. So if you want to know how to do it, and I got this from this example here for Java, but I did it in Kotlin. So you can have this interfaces. You can you can inherit multiple interfaces. So here's all the three interfaces here that are being inherited. And the secret sauce is right here, where you have to say, I want the add one or the add two. So you can even have three of them. I've got an example here with three of them. You still have to do the picking thing, which is just, why are you doing this? Why? Okay, now that you know how to do it, why would you do this? Let me know in the comments below if there's any particular reason that you found why anyone would want to do that. Next up is going to be some thoughts on software complexity. Wait, let me see. Oh, no, I could do it in this one. That's right. So this brings up this whole question, like complexity. It's like, why are you doing these things? And I'm going to do a little cartoon here. Where's my cartoon? The cartoon here. Most programmers spend the first 5 years of their careers mastering complexity, dealing with all this crazy stuff. Let's slap that in there. Let's do this. Let's up that. And then you realize, okay, we're probably not going to need 90% of that stuff, 80% of it. We can just concentrate on this 20%, make it work, and only bring in what we need if we actually have to do it, and somehow sequester that away so it doesn't break our other stuff, just and go through our entire code base. So let's go see what Jonathan Crosland has to say about complexity. By the way, he's awesome. Go over and give him a like and subscribe. His stuff is super underrated.
I'm shallow. I like
Start over.
I'm shallow. I like very shallow classes. I like shallow classes instead of deep classes, and I'm not ashamed of it. I like simplicity. I like things that are simple. I like simple constructs and elegant things. I don't like it when people just build stuff for the sake of building stuff in all kinds of strange ways, right? I think there's two things. There's stupidity, and then there's the investment in complexity.
Right, because some people want to pad their resumes, and I understand. Yes, in a competitive environment, I get it. But if you're working on your own stuff or like starting just doing your own startups, you really need to stop doing that. That's gonna get you going down the wrong path and possibly your project killed. So this is what we're talking about. We're talking about trying to not maximize efficiency, but like don't do things that aren't necessary just for the sake of doing them, because the new GWiz Bang thing just came up off a lot. And we want to do microservices now, even though we have more servers than customers.
So let's look at stupidity first. You know that guy that develops code where you have to read it 5 times just to understand it? The guy that just does everything in promises and promises and promises and promises in series?
So he's talking about just like linking things together, like a bunch of if statements. If. Like it is a way to program, but man, is that hard to deal with.
Or likes every advanced C# feature and just does everything in one spot. You know what I'm talking about? You know when you've got dependency injection and you like it and you think, well, that's a
dependency injection is just like passing parameters. That's all that is. And it's like people want to throw out these big words for some of this stuff, and it's just such the trivial. Like, why are you guys even discussing this stuff? This is crazy. There's just passing parameters. Gosh.
Injection and you like it and you think, well, that's a good concept. Yeah, that's very sound. And then you put it into everything. Absolutely everything. It's here, there, and there. And everything is just passing an object that you've got to instantiate and pass in and pass in and pass in until you... It's absolutely mind-boggling at the stupidity that's involved in our industry on how we design things and run with things without thinking about who's going to use it. Who is going to use it? Are they going to be able to use it well or easily? There is a learning curve.
It's us. We're going to be the ones using that stuff. And maybe that team member is like padding his resume so he can jet off to the next one in the 2-year time frame, because it's just a factory farm mill, and he just finally got his feature request in. Now he's got his thing on his resume. He can move on. That's coming to an end. That's actually, that trend is kind of coming to an end. So I don't know. That those days are over. We have to do more practical engineering now. Practical computer programming
that you're creating. There's far too much technology that's out there that requires you to learn so much about it when there was no need to design
vendor lock-in
it in that way, right? Good design is levels of abstraction, but you don't have to expose every part of your abstraction to the outside. We call it a black box, right? A black box is a nice thing that we want to get to. We don't want gray boxes and white boxes. We don't want things that exposes its internals to everyone else.
So that exposing the internals to everyone else, this is what he's talking about. He's talking about this stuff. You got to know, is it the dog? Is it the cat? You have to know the internals of here, not just make a sound. Whatever it is, make a sound. No, oh, now I got to know. Oh, if it's a dog, I do this. If it's a cat, it's like that's completely like upside down on the abstraction layers. And now we're going deeper. We have to go now. We have to know details, all these implementation details. So we basically went from having this kind of structure, right? We're having this tree. There's no loops. There's no loop backs. To this. And this is what we're talking about, the spaghetti. So we're trying to not do this unless we have to. Staying like this as long as possible until we have to do something like this, right? Because this just gets nuts. Let's keep going with complexity. Let's backboard set up a little bit. There we go. Why does it do that?
That we want to get to. We don't want gray boxes and white boxes. We don't want things that exposes its internals to everyone else, right? If you're going to build something, we need to build that layer correctly so that the guy on top can read it and use it with low learning curve, and it's helpful. Complexity is not something we should try and go for, and I should qualify that. We're talking about needless complexity. There are things in life that are complex, but
we're talking about the needless stuff, the extra stuff. Can we not have to do that stuff? If we can get away with not doing it, we're going to make ourselves doing big favors in the future.
There is a sophistication and elegance in making those complex things simpler. That's where we should be looking.
That's the knowledge work. That's the stuff that AI is going to have a real hard time dealing with. That's why these are going to. This is going to be the real programmer thing in the future. Is like understanding what the capabilities of the machine are and how we can apply them without going overboard and doing every gee whiz bang new conference driven development. We do throwaway development. We do a few models until we kind of get into the space where it's kind of sweet. Then we start building. This is how we're going to be making stuff.
The second thing is this investment in complexity. Business has this investment. They sell courses to describe their applications.
Oh, you don't think that those aren't just sales sessions? Oh, they're just teaching you all the things you need to know. Oh, without their lock-in and their spin on it and their way of putting the problem together? No? Never heard of it? Never heard of a sales call? Never been in an MLM? Never been to an MLM meeting? These software people sometimes are just like, have you ever been out in the business world? Because it's sales driven, man. This thing is sales driven. And I love it. But realize what it is when you go to these conferences and these guys get on stage. They look so sharp and they tell you all the things that have happened that were so amazing for their project. Not necessarily your project. That's the thing they slip by. It's like, oh, they're talking about their project, but they say, it must be my project too. Let me put some multiple inheritance in there. That'll make it work better. Because the conference guy with the suit on told me I'm going to get my stuff on time because I got multiple inheritance.
They make things deliberately complicated, or at least allow developers to not really think about it and make it complex, maybe by accident, right?
Like by accident. Oh, it's just all of a sudden it's just way more complicated than it needs to be. And now I'm stuck on your platform for 5 years until I can figure out how to get out of it.
Pretty complicated, or at least allow developers to not really think about it and make it complex, maybe by accident, right? But they use it. They use it to sell courses and peripheral kinds of things, and it's not required. What happened to that simple application? You can click, you can go in, it's intuitive, you can just use it. Well, a lot of people think that's too hard to do. It's not really too hard to do. It's just simplifying and simplifying, right?
Yeah.
It's a very important.
Yeah, the job of simplification is what happens after going down some of these rabbit holes of, well, let's make it more, put every bell whistle widget on there. It's like, okay. There's a time, place for that. There's a time, place, okay, to pull back. And, knowing when that had to do that is kind of maybe start doing that early. That's why I'm talking about this early in these sessions. Like, not early in these sessions, but like if you're just learning about programming from me for the first time or whatever, this stuff's super important. This is the work. It's not the typey coding language. No, it's this stuff.
Important concept. So first of all, we've got that developer, the one that likes to build everything in Lambda or build everything in regex, right? We've got people who want to.
The Lambda is like this function call style that was super popular when you're talking about it. And regex is this little tiny language that does all this super sophisticated text processing, but it's like incredibly difficult to learn. And then to see someone else's code like debug what the heck's going on. Now it's very useful. You will probably have to learn it, but still it's like, guys, are you serious? It's like 60 years old. Do we have anything better yet? No, we don't.
Well, we've got that developer, the one that likes to build everything in Lambda or build everything in regex, right? We've got people who want extension methods everywhere, and you never know where the hell that thing's coming from. Or why do developers do that? Why? Are you trying to show how good you are?
Yeah, some are. Some have shortcuts. Some have got deadlines to do, and they just want to get it done this week. Some of their company's about to go under. I'm about to get acquired. I have to get this feature in by Tuesday. If I'm not going to get the funding and the funding happens and my thing gets acquired, I'm now VP and I'm bringing in people underneath me. And now you're on the project. That's why.
I believe the guy that is truly good, the girl that is truly good at coding is the one that makes it simpler for me. I don't have to go back and ask them all the time, what did you do here? Why doesn't it work like that?
Yeah. The least, what is it called? The coding for the least surprise. It's like, oh, this makes sense. It's kind of what and that's, you only get a feel for this after doing it for a while, but like, and then having a code base that looks good and versus what learning one that's bad. Oh, this is why we have so much fun. This is why the computer science academics, they kind of fell down about 30 years ago on this stuff. They should have been teaching this kind of like level of thing. This guy's PhD level on this stuff.
Where do I put this thing? Oh, that's in the config. Oh, that's a dependency injection. Oh, you see what you didn't do there is you didn't slip in this thing in the pipeline. Oh, you didn't do this. You can make things easier than that. You don't have to put forward everything that's complicated. And in the case of dependency injection, you can design something that has convention over configuration. Don't make it a rule that I have to provide you with everything. Right? So with everything that you do, there's a pro and con. And
so the convention of a configuration means like just set it up the default way. Give me some parameters in there, but set it up the default so it works out of the box like I would think. But if you want to put some bells and whistles in there, let me do that. But make that an extra layer underneath. Like do the simple one up top and the more complicated stuff at the bottom. Or there's a default way to do it, an opinionated way. There's like the normal way to do it, and then if you want to like go mech with it, we've made a mechanism for that, right? But the standard way is not all the. Don't expose all the bells and whistles. Just a knob or two, maybe a switch. You know, does this make sense? No. Okay.
Our designs have to be thought through all the way so that we're not providing that learning curve to the outside, because that's what abstractions are supposed to do. Make it simpler. Right? We get that wrong. We get this extremely wrong in the industry. I especially don't care for the companies that prey on it. And it suits business to make complicated stuff. Right?
It certainly does. We're talking about sales, man. So I mean, we have like I am totally down for all this stuff. Just if like the fact that you're listening to me at all, just realize this is a sales driven thing. People are here making money. We're not doing it for our health. I mean, it was fun when I first started. Like that was the thing. But now it's we're trying to make money, and we're trying to make it efficiently, and we're trying to enjoy ourselves at the same time and not kill ourselves with these projects and do ridiculous things. We're not trying to. If you're trying to impress somebody about your coding, nobody cares except people on your team about how easy it is to learn their stuff and fix it and change it and modify it and add stuff to it and delete stuff. That's what makes it a beautiful place and like a fun thing to do. But when you're not doing that, if you're just trying to make things more difficult because the conference guy, sales guy said that you got to go do it this way, no.
And to me, like you go to a seminar and you sit in there and you're hearing all these buzzwords that, in the documentation and stuff that you've read, and you're thinking, okay, well, it'll be a good thing. Let me go to the seminar, you buy your ticket, you go there, and you rock up and those terms, well, they're simple. It's not interesting. Oh, is that what they meant? Oh, is that what it is? It's.
Oh, is that all they meant? Oh, is that what they're talking about? They won't sell the ticket, right? So part of the hypnotic induction techniques these guys are using to convince people to go get into this stuff is bamboozling them with bullshit. Because what that does is while your conscious brain is trying to figure out what this word means, they're installing all kinds of information that's going right past your conscious brain while it's doing this, completely bypassing it, right into the subconscious. So a lot of these people don't understand that these are sales tactics being used. Sometimes for legit progress, oftentimes not. There's an other way it's doing that they're not going to talk about ever. This is computer business. This is computer industry. This is what we're going to deal with. It's kind of fun, but also kind of shitty. But it's not going away ever.
They're simple. It's not interesting. Oh, is that what they meant? Oh, is that what it is? It's rubbish, and the industry is built up, and it's frightening, and quite frankly, it's appalling, right? It's the amount of stuff.
I mean, that's why I'm doing this series, because it's just kind of nuts.
That we have, the fluff that we have in our industry. So how do you make things simpler? So I've written down 3 things, right? 3 things. You have 3 tips. Number 1, think more about generalization and abstraction. Think more.
Generalization and generalization. my pet peeve word, abstraction.
Think how you can make things normalized, generalized. Think about where the abstractions are going to be. That doesn't mean you expose them. It means think about them, right? Think about how these things can be generalized. It's a very important concepts, right? Generalization and abstraction. Very important. Number 2,
generalization and generalization. I wish we have to get that's abstraction where it means exactly the same. I'll stop.
Expose what's beneath the abstraction so readily. Think black box, right? Don't expose everything. If you're going to expose something, put a layer on top, put a facade layer on top. Right? You're exposing an abstraction, you've got a white box that's necessary, there's going to be a lot of adaptation, a lot of use, and a lot of inheritance to make it do something else. You've got a lot of patterns going on here, and you need a solid white box. Well, put a layer on top, right? Put a layer on top that makes it so easy to just use the default behavior as a black box would.
Please think about doing that, please.
Number 3, fight those. Fight those that say, I know this thing that I want is similar to that thing, but, it's different. It's different, and we're going to have to do this and then tweak that, and I want a new menu item, and then that menu item will click. Fight that.
So he's talking about making this abstract or like generalized thing and then putting all kinds of switches in as opposed to putting 2 different things. Just because they kind of look together doesn't mean they are. Right? You've really got to think that stuff through, because by taking something and generalizing and put a bunch of buttons, you just overcomplicate something that would have been just easier separated.
Right? Always look for the generalization. Right? Complexity comes from the distinguishing of concepts. If you need to distinguish between this and that, and you've got an if statement or a switch, or you've got some kind of non-polymorphic thing going on, you're adding complexity to the system. right? If you don't have, if you have a lot of configuration and not a lot of convention, and you also have to distinguish between these things, your code is a lot more complicated than somebody who's decided on a polymorphic convention over configuration black box scenario. In terms of learning curve, one is clearly the best. In terms of modifiability, one is clearly the best. In terms of external interfaces and how it touches on other code, one is clearly the best.
And that's what we're trying to go after. So we're not trying to just write the code the first time. We're trying to make it so we can swap the stuff out easy at some point, because everything gets changed all the time. And the easier we can make, and like find out where the boundaries are, and then make interfaces between those, some kind of plugin interface where we can just swap things in and out. It makes our lives a lot easier because we're going to be asked to change this stuff all the time. So it's not the writing of it that's the hard part; it's the maintaining of it and modifying it. That's the hard stuff. And that's this next frontier is why we're talking about the COP. It doesn't really lend itself for that, but the boop style kind of does. And this, he's referring, a lot of his ideas are the boop style stuff, which we'll get into.
We have to work towards simplicity. Lastly, let me say this. Simplicity is something to fight for. Leonardo da Vinci once said, simplicity is the ultimate sophistication.
Yeah. Yeah, if you can simplify something, it is a sophistication level. Okay, let's see here. All right, so we're going to be, I got thoughts on the complexity. How many? We're 25 minutes in. Okay, I want to do this one. Big design up front. This one's also useful.
Big design up front. It's a dirty word. It's a dirty term, right? Design is a dirty word.
I've been at several of these companies, not several, a couple, that were just no design at all. Just start coding. And it's like step on each other's toes. Everyone's super confused. Like, what are we building? What does this mean? Why are we doing it this way? What libraries are we going to use? No, just start coding. It's like, okay, no, we don't even know what we're building. Like, what are we building? It's like, doesn't matter. Just get in there and show us. Just try and make something work. Okay, so I'll be out front. I'm a big fan of some design up front. Not all design up front, not big design up front. That's definitely a stalemate operation. That's never going to go anywhere. But some design up front and design as we go along. Like, kind of at least think about what we're trying to achieve here. Like in the Mythical Man Month, you have to have a goal you're heading towards. So figure out what that goal is before you start marching down the road.
It's been tied to waterfall like a bad rash. You will have to design everything up front, the whole system, define absolutely everything. You'll have to do this, and we can't know what we're designing for. How can we predict the future? Business changes. Business is supposed to be agile. How on earth are we going to design everything up front? You know, and like maybe we should refactor in small little steps and get there. You know, maybe we'll fine tune things, right? Designing up front is really wrong. You know, this is the prevailing wind. The problem is that design is like a knee-jerk reaction, like going away from that. So design is like, you know, it's so dirty, we don't use that. We don't use it in iterations. We sort of shy away from it. And this sort of like designing, going to the outskirts has actually been quite damaging. So, okay, so I've written down some of the issues, and I'm just going to look at, you know, two of them, right? So I'm going to look at design, I'm going to look at over engineering. Okay, so design in general. So number one, it doesn't have to be up front. It could be within. It could be just in time, right? It doesn't have to be big. It could be small, right?
I'm a big fan of the throw away two and build one. And don't tell anybody you're throwing them my way. Or maybe, I don't know, it depends. Like, you gotta do some prototypes. And those prototypes you have to let people know, these are gonna be thrown away. But we're gonna fight, through this method, we're gonna find it, we're gonna build a slice of it, we're gonna build a piece of it end to end. And we're gonna see what happens along that way. And we're gonna discover stuff, and by the time we get to the third one, we're gonna know so much about building those two that we are probably gonna be very close to what we actually want it to do by the time we hit the third one. I don't know if you noticed this about software, but the third version is usually pretty on target. The first one, no.
Could be little things, right? Could be just the right things, right? Maybe the architecture, the things that are difficult to change within the system, when you want to design that properly, right? Make sure that you don't run into problems halfway through. That's part of being agile, right? It's designing something so well that it can move around, right? Moving around is not just the act.
But you only do that by doing the prototype stuff. And so the agile thing is not necessarily to get you there faster. It's to get you there, get to where you want to go, right? So if you're going 100 miles an hour in the wrong direction, you know, doing 3 miles an hour in the right direction, you're going to get there a lot faster going at 3 miles an hour. That's the whole thing. And yeah, it's just people really misunderstand the whole point of it. It's not to get to the code faster. It's because it's a sprint. It's like, no, 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 we should call that something else. I'm gonna do probably a whole series about the style I would like to see for project management. That if you want to get maximum creativity out of people and make them want to stick around after the project's finished.
To being a developer and going, I'm agile, I can code this and now I can code that, and we only work in an iteration of 1 week, so I can swap to something like this and swap to something like that. That's not what agile is. Agile, a large part of it will be the design, right? If the architecture doesn't fit where you want to go, you got big problems.
Right, the agile, the architecture has to be set in to be agile. You have to set it up. You have to think about it ahead of time. The things that are going to change and things that are going to be swapped out. You have to think, and the only way you can kind of do that is by building it. Sorry. I know it sucks. We want to start right now and be done in 6 months. Yeah, you can do that. You can build the 1.0 and hit it in 6 months, but once you get that 6 month mark, if you build it like that, chances of failure are very high. Now, if you build it a little bit, go a month, and if you see how far you're down the road, it's like, okay, is this looking like the right direction? You'll have something to show and something to play with. And you can say yes or no. It's like, oh, we didn't mean that, or we did mean that, but we need to do this over here. People don't know what they want until it's in front of them. So you have to get in front of them, and you have to have a design that's going to be built to flex. So you may have to do some prototypes and then build the architecture. No? Does that make sense? Okay.
Right, so design shouldn't be a dirty word, but it is. And if you're designing a garden, you don't just hop onto your favorite nursery e-commerce website and order a bunch of random things, and somehow it'll arrive in some date, and you go out there and you plonk everything down in different places. Right? You don't place things wherever. You don't willy-nilly do that. No, you go out and you go into your yard and you go and have a look, and you get a piece of paper and you see where the shade is and where the path might be, and you have a look. You see, you feel it, right? You try and understand what would be livable, what would be good, what you want to look at. When you look in that direction, I would like a tree, I want some flowers. Oh, I can't put it there because there's too much shade, right? So you obviously wouldn't just emerge.
And with software, we don't have to build one garden. We can make prototype gardens. Do you mean like this? Do you want the flowers over here? Do you want these over here? Oh, you want the beets and the vegetables have to be over. Oh, okay, they have to be. The lettuce has to be over here because, and the chicken coop here. And you want a movable chicken coop. Oh, okay, so we need to put different sizes. Does that make sense? And with software, you can wreck it and start over, and the garden will be fine.
Design that backyard, you'd want some kind of design. It doesn't have to be everything. But then again, you go to the nursery, you bring back a shrub that caught your eye, you plant it somewhere and it dies because it's not in the right area, right? So big design, number one, doesn't have to be big. It doesn't have to be up front. But boy, do you need it for some things. Boy, do you need it for architectural.
I need it for the whole way through, the whole thing. Every single decision, by the way, is architecture. How you think about the problem, your procedure, your approach, your philosophy, what you think is important, what's not important, what to focus on, what not to focus on. This is the curation of humans, for the taste of other humans. And the tastes change, and priorities change, and requirements change. And the AI will never going to keep up with that stuff. Not like a human's going to be able to with the human touch. Because we are the humans that are going to be experiencing these things. So only we can really understand what's going on. Now, we're going to guide these machines. These machines will be guided by us, of course. But it's going to be up to us to curate this stuff.
It doesn't have to be up front. But boy, do you need it for some things. Boy, do you need it for architectural type things. Things that are part of the core. So you do need design. You just need a good place for it, right? You need to integrate it into your systems in a good way. And of course, you need a good designer. Let's look at over engineering, right? So
we're all designers. We all have, because we're all in this world. We're all living in this world. We're all experiencing these things. So we're all designing these experiences.
Things like UML, design, architecture, it's like all in the realm of that beardy hat wearing, old fart wearing sandals, right? So yeah, this can happen. People can over-engineer, right? And you can spend a lot of time.
Definitely can over-engineer. That's why you got to start building the process. Start building something. Or is this what you mean? Oh, wasn't that? Oh, you mean this thing over here? Like, if you don't know what the architecture is, let's start trying for this like, you have to be aware that there's an architecture you're going to have to decide on one. What it is in the beginning, we don't know. Okay, we'll just put one together, but we're not going to keep going with this. This is a learning exercise. This is an adventuring expedition. And we're going to have multiple expeditions. We don't know how long it's going to take to get over that mountain. We can expedition go over that way. We can expedition go over that way. But we're adventuring, right? We don't know if we're going to actually hit gold or not. But if you don't climb the mountain, you'll never hit gold, right? You don't try a path, you're never going to hit gold, right? Does it make sense? No?
time on something more than you should have, and yes, it could be a waste of money. But the thing is, it can be combated. Well, how do you combat it? Well, make sure it's needed. Make sure you design with constraints. Make sure you design something that's needed, and the proportional amount of time that you spend designing proportionally on the amount of time it takes to develop, right? I mean, ensure the implementation is going to happen within your budget, right? These are constraints that a designer works with. Now, if you can't do that, well, then you're not a designer. A designer has a set of constraints and works within the constraints. That's what it's about. And over-engineering, if you do have somebody that's over-engineering, replace them. It's almost as simple as that.
Brutal. But sometimes these organizations that do it, they're paying you, like, and you're fine with it, and you're learning, okay. But it does get a little grindy.
Right? It doesn't have to be over-engineered. Somebody doesn't have to sit down and do UML of everything. Right? So this leads
Definitely don't do that.
us to one of the thoughts. Like, if it's not big design up front, well, then it must be something else, right? Like emergent design. Okay, so emergent design is it's not valuable, right? It's only valuable when the design presents itself at some strange scenario that you didn't foresee. Something happened, something changed, and then the business had to go here and there, and there's this design emerging, right? We're improving it all the time.
This is from doing the prototypes. This comes from doing the prototypes.
Well, that, I put to you, is an edge case. That happens occasionally. That shouldn't be the thing you design. It shouldn't be the way you design. It should be the way that you operate. You don't operate on edge cases as the norm. You operate...
I mean, the only way you're going to find the edge case, maybe the edge case is important, right? The only way to find that stuff is to have it put in the hands of users that actually try and manipulate and play with it and realize this is an iterative process in a lot of ways, but in a lot of ways, it's also a design of someone who has a vision of how this is supposed to work. So it's a combination of those things. It's having a vision about how it's supposed to work and coming together with the people that are actually going to be using it and seeing if we can make a compromise that's beneficial for everyone involved. Right? It's difficult to do that. And a lot of times you're going to have to go with a designer, and he's, his success in the market will fall whether his intuition is correct or not, or the team that's puts us together, whether their intuition is correct or not. The market will tell you, yes, you got it, or no, you don't. Or you can ask them and be an iterative, like, do you mean that this over here, or that over there? But you can't let them get in control of it. You still have to be in control of it. So this is the art, right? So this is art. This is the art.
Operate on the norm and have edge cases. Emergent design is it doesn't have any value. So if it doesn't have any value, why do you use it? Why would you even consider emerging a design? Well, emergent design might have some heuristics and good principles that you can encounter when you hit that edge case. Fantastic. Right, so emergent design inherently has no value. A subset of that, I just want to bring up, like, the entire...
I mean, he's saying that you can't just start from scratch and do random stuff, and it'll just come out. It's like... It's not, you will get something out of that, but it's probably not going to be what you want.
Entire design, a big design up front, does it really have to be the entire design? And if you think that big design up front is tied to design and architecture and beardy old men and all that kind of stuff, antiquated ideas, well, if you think of all that, well, then you've misunderstood big design up front then. Because I thought big design up front is designing absolutely every angle before you write a stitch of code.
Right, so the design up front would be like, okay, I'm making a spreadsheet. It's going to have cells, I'm going to have formulas, but I'm going to have some sort of graphing thing somewhere, and it's going to calculate somehow. But I don't know much more about that. But we're definitely making a spreadsheet. It's going to have cells. People get it's that kind of thing. It's not like, oh, here's a word processor. It's like, how did that get? We don't know. That's not what we want. We want the Excel with the numbers and the graphs and all that stuff. Well, how about a 3D game called Asteroids? Like, are you even listening?
But then, if that was true, why is it that people aren't doing any design at all? Right? So yeah, if you go and download your favorite thing, right, whatever it might be, right, the Docker or whatever tool, right, I bet that's been designed, right? You don't come across these things by accident, right? People look into it, they research it, they have constraints, they have a function, that functionality they want to reach, and they design something for it. Right? I'll be very surprised if somebody comes back and says, Windows was an emergent design. Yes, it has been designed and refactored and moved and worked, but let me tell you, there is a design there, right? There is a design. And the same is true in anything that has real value. And remember, in different industries, a certain level of design is not going to go amiss. If I'm building a flight control system or a navigation system or controlling airplanes, am I not going to want to design that a bit? Well, of course I am. So number one, let's get rid of the idea that big design up front is this negative thing. It's the connotations around it that people just place around it and sort of group it all together and group old-fashioned engineering and UML and all these things.
Confound things together. There's a lot of confounding. Throwing a baby out with bathwater stuff that happens, and a lot of these ASPE guys are super get triggered when their idea isn't being the thing that's going to be the 100% winner in all categories of all things. Somebody needs to teach those guys some social skills because they've ruined projects.
All in the same basket. It's not. And yes, it's true that guys were using UML and using bad tools and overusing tools. So do we today. We're using Kubernetes and Docker for things we don't even need, right? I mean, it's true then, it's true today. Just like you have a business vision, you should have an architectural vision. And I think the team should know where they're going. And there has to be elements of design within that. And I think it's always understanding constraints and then delivering constraints to subsystems. That's a very, very important part, because if
That's engineering. Yeah, it's just engineering mindset.
all your developers are working in opposite directions, you're not going to get that familiarity and you're not going to get that consistency. So it's very, very important. Lastly, I'll leave you with this. I've written it down so I don't get it wrong. A good designer will understand the constraints and will never design to the detriment of the business. And if he designs for the sake of design, hire someone else.
Exactly. All right. I think that's about it for this episode. Yep. Next one we'll be getting. Oh, so this one's on naming things. I might bring that up in names things, and we'll talk a little bit about design patterns and some stuff like that. And getting towards the end of the COP, gonna get up to the what's the one after them? The functional. Get into the functional. Going back to the 50s. All right. I'm Chris. Give me a like and subscribe or not. I'll talk to you soon.